Welcome. This is Happy Healthy Cows, the show where we chat with experts about all things that keep dairy cows comfortable and happy. We will talk freestall bedding, manure management, barn design, ventilation, and all the details that make a big difference. After all, comfortable cows are the foundation of a healthy herd and successful dairy production. When cows are happy, dairy farms run better. Hello, I'm Renee Schrift, and I'm your host today. And I'm with McClanahan Corporation, and I'm the global director for sales and the agricultural product lines that we offer. And today our podcast is titled Sand Separation and Anaerobic Digestions Working Together Successfully. And our guest today is Dr. Dana Kirk, and he is with SKS Development, and he is a partner with that company. So Dana, how about you tell us a little bit about yourself, your background, your education, and what's led you to SKS Development and being a partner in that today.
Yeah, thanks, Renee, for having me. So I guess background, grew up kind of in the dairy industry on a small dairy farm in central Michigan. Started working with Bill Bickert at Michigan State when I was in high school as part of a 4-H project that got me connected to sand bedding and cow comfort and all of those kind of topics of the late 1990s. Completed my undergrad at Michigan State and then continued on to do a master's degree and PhD with Bill. The PhD was focused on sand separation as it impacts anaerobic digestion. So fast forward, did consulting for a number of years, went to Michigan State as a associate professor for about 15 years and left in 2023 to take on a full-time role with SKS and Taurus and kind of lead their development and operational efficiency efforts.
McClanahan has had a chance and an opportunity to work with you more and more as time has marched on. And I think with the dairies in Michigan, and you kind of said it there with being in Michigan and that experience with sand. I mean, sand has been an important part of the dairy industry. But when I think about all the years of experience that you have and that Dr. Bill Bickert, the name you mentioned, sand was kind of like, a really progressive thing for the state of Michigan, right? And just the dairy farms there just embracing it and using it for all the comfortable reasons that we use it today.
Yeah, sand's very abundant in Michigan, being just kind of positioned between the Great Lakes and in the glacial area that we're at. So it's abundant. It's traditionally been an inexpensive bedding material. It's very clean, drains well, conforms to the body. So it has kind of all of the attributes that you look for when it comes to bedding on cows. And my family's dairy when I was young was using sand bedding in the early 80s. So it's not a new thing for Michigan dairies to have sand bedding on their farms.
And then the sand separation systems were primarily developed there, and McClanahan got involved in that. And when I met you back in 2000, I think 2001, when I started with McClanahan Corporation, like you said, you were just getting into that master's program on the digestion side, and that's kind of where our paths had crossed at the time. Talk a little bit about how you perceive the anaerobic digestion piece and how that's fitting into dairies and how it fit then back in when you were doing your master's and PhD program, fast forward to today.
Yeah. So when I started my master's, permitting of farms was kind of the new thing. So there were things changing at the EPA and farms were getting put under NPDES permits. And so that was a big change for the industry. And what that leads to is really kind of a more intentional focus on manure management, how we do land application, how we utilize nutrients, and then all of the things that lead from the barn to, maximizing the utilization or improving utilization of nutrients. Digestion came kind of in I guess it would be the second wave of anaerobic digestion. The first one occurred with the energy crisis in the 70s and early 80s, where there were some digesters built on farms around the country. But then we had kind of a green wave there in the early to mid 2000s, where a lot of states were passing renewable portfolio standards, and there was a lot of emphasis on green energy. At that time, it was electricity. And so we had several digesters that were built in Michigan and in a number in kind of the surrounding Great Lakes states. Wisconsin was a big leader as far as digesters. But in Michigan, we had the unique challenge of most of our dairies are bed with sand, or we're bed with sand at the time. And so the digesters had to conform or work with kind of the dairy situation. Making milk and having healthy and happy cows is what drives the dairy business, and the digester is, a component of manure treatment on the backside. Renewable energy is a piece of that, but it doesn't, drive how, we keep our cows healthy. So we built several digesters in Michigan. We had one particularly that I was involved with, the Green Meadow Dairy, just up outside of Elsie, Michigan. And that was one of the first digesters that was built on a sand-bedded dairy. And so it was, a lot of focus on mixing, a lot of focus on the sand separation system itself and how it performed. The sand quality or the sand particle size was an important design characteristic. So, a lot of focus on sand. Then as those renewable portfolio standards expired or became full from wind and solar power, digesters kind of waned through the 2010s until the late 2010s, when renewable natural gas became the exciting topic and kind of the hot new renewable fuel, particularly on dairy farms or swine farms, whether you have low carbon intensity scores or negative carbon intensity scores. So it made the gas from those projects extremely valuable, and has led to kind of the current expansion of digesters across the country on dairy and swine farms.
Okay, good. As far as the sand separation piece, back looking at Green Meadow Farms, just for an example, at that point in time in your career, did you have confidence that these systems could be successful with sand, and what you saw in your experience and your testing and what the results were with the digester? Did you have confidence at that point in time?
Well, we probably didn't know better to not have confidence. So yeah, we had confidence. And it was really, but it was looking at it from an engineering standpoint and saying, okay, we've got sand bedding on farms. We know what that particle size looks like, 2NS, or the fine aggregate that's used in concrete. And we really know how those particles settle, in liquid, in water, in manure. And so if we can overcome their, ability to settle with velocity, then we can keep it in suspension. And if we can design sand recovery systems that, take out sufficient sand so that the residual that goes to the digester is minimal, then we have our best chance of doing that. And so a lot of work was put into looking at, how efficient is a sand manure separator at removing sand? How efficient is a settling basin or a sand lane at removing sand? And then how can we stack technologies or stack approaches to sand removal in a way that we can, pretty confidently achieve 85, 90% sand removal in those systems?
Yeah, we definitely, with McClanahan, stacking equipment is a good way to look at it. We're constantly, trying to figure out the next step, the next phase of sand separation. What is good for the dairies to be reusing back under their cows? Where's that borderline or that cutoff where it's not going to be something that's good to reuse? It's going to harbor a lot of water, solids, et cetera. So it's not going to be clean. So, but we definitely don't want that in the digester either, because it's still settling within the main part of the system. So it's always been, it's a challenge. It continues to be a challenge. You got a chance to work now present day with a lot of systems in Michigan that you've been very instrumental in your team and your company installing and working with. Where do you see the challenges today in some of these systems, and even the size of the herds as they grow too?
So the challenges today, I guess I would start by, it's the design of the system and how does it integrate to the dairy, and then how does sand separation integrate to the digester? So you're trying to solve, both ends of the problem, with one set of technology. And so the dairy wants clean sand, recovered and for reuse purposes to the cows. So they want to make sure that, the sand is as clean as possible. They also want the particle size of the sand to be, what they started with. So they don't want all coarse sand. They don't want all fine sand. They want to have a mix of sand particles or sand sizes so that it gets that, beachy feel when the cow lays down and it moves and doesn't pack in. On the digester side, we want to make sure that we have as little residual sand moving forward to the digester as possible. We also want to make sure or drive that particle size down as small as possible. So, the finer the sand is that's left over, the slower it will settle in the digester. So it requires less energy to keep it from settling, in a digester. And so it's really kind of always balancing that. And, one of the challenges we face is trying to take shortcuts in sand separation. It's expensive to maintain sand separation systems, whether it's a passive sand lane or it's a mechanical system or it's a combination of passive and mechanical. There's a lot that goes into it, whether it's maintaining the equipment and the pumps, cleaning out the sand lanes on a frequent basis so that you're getting maximum sand recovery. It's very, very intentional on how that needs to be done. On the digester side, we haven't, as an industry, done a good job on really thinking about how we mix digesters. Europe is ahead of us on digester technology. They've been deploying thousands of digesters a year for close to 2 decades now, or a decade and a half at least. So, they've got a lot of operational history, but those digesters typically don't operate on farms that use sand bedding. And they're also co-mixed digesters, which is different. So the design of a mixing system for that style digester isn't necessarily appropriate for a digester on a dairy farm that's got residual sand. And so there's a lot of shifting of the philosophy on how we mix digesters in the US or North America. The mixing intensity is, much greater than what those European integrators might be using. So those, finding the right sand separation system to maximize recovery or removal of sand, and then matching it with an appropriate digester mixing system, those are kind of the challenges that face the industry today, at least from my perspective.
Yeah, and where you sit and working primarily with the dairies, I'll say you might have experience with the non-sand bedded dairies as well. I know you do, but what do you see the difference being? Like a dairy that's bedding on sand and has more of an intensive sand separation system that they're managing well. And then you have dairies that are not bedding on sand and choose to use digested manure solids or pressed manure solids. What kind of sand do we see in those types of operations compared to post-sand separation? Is there a big difference?
There is. And it's really just the load of sand. So, if I've got 1,000 cows and I'm bedding with 60 pounds of sand a day, and I get 90% removal, I'm still facing 6,000 pounds of sand coming into my digester a day, theoretically. So that's a big load. Whereas if I'm not bedding with sand, I shouldn't have anywhere near that mass of material flowing into my system. So, but it's also a little bit of false hope to say, if I'm not bedding with sand and I'm bedding with manure solids, then I don't have to worry about sand. Because sand is present everywhere. It's present in the feed. It's present in the wind. So, we designed our digesters to be able to control the internal velocity of the content. So the manure inside that digester, we want to hit minimum, we want to hit a velocity of at least 0.25 feet per second, throughout the entire volume of that digester, regardless if it is a sand-bedded dairy or not, because we want our digesters to run as long as possible between cleanouts. And if we don't take that similar approach on a manure-bedded dairy, a manure solids-bedded dairy, and we get a lot of, just grit from feed and from equipment coming in and out of the buildings, that load of sand will build up, or that load of grit will build up in those tanks, sooner than later, and will shorten the productive life of that, or result in premature cleanouts or more frequent cleanouts of the system. So really it is thinking about how do we minimize the unmixed content of that tank, and how do we ensure ourselves of having a uniform velocity throughout as much of that tank as possible.
So like you said, there's a particle size that's probably tolerable to have enter a digester, and at that particle size, or how you have figured that out, what's suspendable or what's mixable, I guess, to keep it moving through the system, so we don't have these drastic cleanouts. I don't know what cleanouts you've had so far, and what you've seen or why those things have happened. Maybe you can expand a little bit on that, but I see where you're going. It's like there's going to be sand bypass no matter what, whether you're sand bedded area or not, maybe more if you have a sand system, but it's how you agitate it and how you keep it moving.
Correct. I mean, it is. And so we design for what we consider a fine sand particle, being kind of the residual, the average of the residual piece that's going to be going to the digester. And that's about 0.15 millimeters. So based on that tells us we need to have a velocity inside that tank of 0.25 feet per second. So it's a very, straightforward mathematical approach to how we look at it. And, with that Green Meadow system, we probably got more lucky than we were good engineers at the time, but we went, I think it was close to 8 years or more before we actually had to clean out tanks there. So we had a good performing system. Again, we want to not have to enter tanks, inside of 5 years if we don't have to.
Have you had to do that yet with the systems that you have, as based on the age of that system and the fact that there was something that settled, not something catastrophic or something that happens on the front side of it and the construction side of it? But what is your experience with cleaning out?
Yeah, so with our current set of systems, we haven't hit that mark yet. We've got some 2 or 3 years, 4 years of operation on some digester tanks that we have not had to clean out. So we're still kind of leaning into where that's going to sit as far as that clean out frequency.
As far as talking about the amount of sand that can get into a digester and knowing that you have to put the engineering behind it and also design for that, not very many digester companies talk about that. So, that's based on your experience and the wealth of information that you have from the past 25 years of working with these things very intimately, because you don't always get that from everybody as far as planning ahead and what you need to do.
As a designer, as we design and operate plants, again, we're constantly communicating up and down that chain about, okay, what's happening on the operation side? What are we seeing and how can we use that to inform the engineers or the design side of it and make sure that we're thinking about, these issues so that we're not repeating mistakes.
Repeating mistakes. Yep. So in your mind, what improvements do you think really need to take place with integrating these types of systems together?
For us, the way we look at it is, we always, and this goes back to probably my research at Michigan State. When we design a sand separation, we're going to have always 3 steps in the process. So, the first primary separation approach, whether it's passive or mechanical, and most of the time for us it's mechanical, should get 70 to 80% of the sand out. And then that next step, whether again it's passive or mechanical, whether it's a cyclone or hydrocyclone or a sand lane or basin, should get another 5 to 10%. And then that third step should assure us that we've got an additional 5 to 10% removal. So our philosophy is just, we have to stack these up in a way, because there's a lot of variabilities day in and day out on a dairy farm, whether it's weather, herd, manure collection, operators making mistakes. And then, maybe you could get by with, 2 levels of sand separation most of the time, but you just lose that extra layer of insurance or extra layer of redundancy by not having, kind of a 3-step process. So for us, we've just found that works well and really gives us kind of the most consistent high recovery or high removal of sand from the manure stream.
Yeah. And I think back to whenever you were working through the digester there in Elsie, Michigan at Green Meadow Farms. And, we kind of were stumbling across that at the time by adding hydrocyclones into the mix. That's right when McClanahan really started working with them and trying to figure out and validate the performance of those and what we were going to get. And is that sand acceptable to put back in the recycled sand pile for the dairies to reuse? How does that impact the return on investment for these dairies? But then at the same time, it was really about overall sand recovery. So stumbling across like taking the overflow and putting it through a little settling area and figuring out what that accomplished. And like you said, it comes down to the management of it and how you take care of those systems and maintain those systems to have success and efficiencies.
It's also how you put them together, how you put the pieces of the system together. So, the placement of, if you're going to use a hydrocyclone is one of the steps, the second or third step in the process. What do you do with that underflow? And if you put it in location A, is it advantageous for the system, or does it actually add fine sand back to someplace that you don't want it? So, really kind of purposely managing, where those are positioned and how you manage the products, the underflow and the overflow off a sand lane does have also an impact on how the systems perform. So it's not just the pieces of equipment, but it is actually being very intentional about where and how you assemble those.
Yeah, no, very important point. Moving forward with just the anaerobic digestion, I'll say movement and where our dairy industry, where our country is going with anaerobic digestion. Do you have any food for thought, or just like where that potential is or where it's headed? What's the future?
I think we're at a little bit of a holding pattern right now as an industry. There's been a lot of changes to policy, a lot of new systems that have been built, and so you've got a little bit of market saturation going on. So, prices are down from where they were, 3 years ago or 5 years ago. As digester operators, we're also learning about the cost of operating systems, and they're not easy to operate, and they do take resources, human resources, as well as financial resources to maintain and test and evaluate. So on the dairy space, the digester industry is a little bit probably in limbo right now when we don't see a lot of new plants being built today. I think the expectation is that markets are going to improve, opportunities to sell low carbon intensity or negative carbon intensity gas is going to improve again, and those will come back. But we're just kind of in a period of sorting it out. And we've been stagnant for a year, plus now, and we're probably looking at another year or two where we're going to see some stagnation and not a lot of new development on dairy farms.
Maybe not new development on dairy farms, but I think, just in my opinion and view of it, there's a lot of improving that needs to be done on existing systems that are out there that might not even be operating at this point in time. And it seems like there's a niche opportunity for especially companies like SKS who have the know-how and the wherewithal and the experience, the depth of experience with your team to go in and look at these systems and evaluate whether you want to, move them forward.
Yeah, correct. I think part of what we're experiencing right now is that high operating cost that's much higher than what was probably budgeted in most pro formas. And so, it's understanding, okay, how can we invest a little bit of capital to improve sand removal, improve mixing, modify our mixing or sand separation regimes, and really maximize the operational length or lifetime of a digester between cleanouts. So again, if you think about having to clean out a digester tank, it's going to take a month to empty it. It's going to take, a month to clean it. It's going to take a month to refill it roughly. So, you're looking at 2 to 3 months minimum of downtime on a digester cleanout. Plus, so that's lost revenue. You've got operations sitting on the sidelines, and then you've got the cost of actually doing that activity. So it is really disruptive and impactful to a pro forma of a digester. So extending that from 2 years to 4 years or longer has big implications on the financial viability of a digester.
Okay. No, very good. As we start to wrap up here, is there anything else that you'd like to share on the success side of what you guys are doing and how you're working with the dairy industry?
No, I think, we're having success on our operation side and having good uptime and productivity on the digesters. I think we're always learning and we're working more kind of with our counterparts in the industry on the development side or operations side to utilize more of our expertise in the engineering and design side of digesters and mixing systems. So, I guess modest successes, but it's still a young industry that's learning and evolving.
Right, exactly. Well, I think you highlighted so many good points today. I thank you for your input and your experience, obviously, and your depth of conversation. I think there's a lot of good information here. So thank you for joining. Thanks for listening to Happy Healthy Cows. Be sure to subscribe on your favorite listening app and follow Happy Healthy Cows on Instagram, TikTok for more educational cow content. Here's to healthier herds.